Hello ladies and gentlemen, we're going to do some modeling today. So this is some pretty fancy stuff. You're definitely going to need Desmos. And we're going to just do a couple types of problems today. We're going to do some volume problems and we're going to do some perimeter area problems. So the goal is to maximize something. The first problem here is a cereal box problem. So it says Kellogg's is designing a new box for Frosted Flakes. And we've got the logos. What we just need to do is make sure that we can now scale it appropriately. So it says, find a function that models the volume in terms of its depth x. So when I say depth, I'm going to call this guy x. So if this, imagine this is your prism here, the depth will be how far back it goes. So that's the depth. When I say in terms of it, I'm going to try and write this as a function. So I want v of x, which means on this side I'm only allowed to use x's. And you're going to see what I mean in a second here. First thing it says, the width must be 3 times the depth. So if this is the depth and this must be the width 3 times, that would be 3x. And it also says the height is 4 times the depth. So if this is the height of the box, that's 4x. So here, everything that I'm given is in terms of the depth. And if I wanted to find the volume of this prism, I would multiply the width times the depth times the height. So it would look something like 3x times x times 4x, which then I can rewrite as 3 times 4 is 12, and x times x times x is x cubed. So what I have here is the volume if you just give me the depth. If you give me just one of these dimensions, then I can tell you the volume of the whole thing. All I need to know is the depth, and that's what it means when it says volume in terms of depth. If you give me the depth, I can give you the volume. Here's the formula. So if you give me the depth is 2, in function notation, that means I'm going to plug in 2. So 12 times 2 cubed. Now, you can use your calculator here, but this is 8 times 12, which is 96. So this will be 96, and this is what kind of dimensions here? Do we know? Inches. Oh, inches cubed. Right here, inches. So if they give you 2 and you plug it in, you're going to do 2 cubed, which is 8, and 8 times 12 is 96. So if this was 2, if the depth was 2, then the volume of the whole thing would be 96. And you can kind of think about it as being like 2 times 6 times 12, and you get the same thing. Wait, 2 times 6 times, oh, 8. This would be 8, yeah, okay. 2 times 6 times 8, and you get 96 that way too. But we have the formula, so we just plug it in. Now the next thing says, if it's 192 inches, then what should the dimensions be? So that's working backwards. Here I'm giving you the volume. So instead of knowing the input, the depth, I know the output, the volume. So I'm going to say 192 equals, and then I'm going to write my equation, 12x cubed. So to solve this, you would divide both sides by 12, and I have Desmos here, so I'll try to show you how to use that. You would do something like 192 over 12, 192 divided by 12, and that gets you, 16. So I know that then I have 16 is x cubed, and to undo cubing something, we're going to take the cube root. So I'm going to take the cube root. Now you can do that in Desmos using the root tool, which there is a button for it in here somewhere. Let's see, can I find it? Maybe I'll just type it. Just do nth root. There you go. If I want the third root of 16, I get that. So it's about 2.52. So this is about 2.52 inches will be x. So if you want a volume of 192, you want to make the depth 2.52. Now it does say what are the dimensions. So I know the depth, x, would be 2.52. The width would be triple that, and the height would be quadruple that, because that's what they told us at the beginning. So triple that, 7.56, I think. This would be inches and inches. We can use Desmos again. So I'll say 2.52 times 3, 7.56, 2.52 times 4, 10.08. Great. So that would be the height would be 10.08. Just make sure that you answer the questions. If it asks you for the dimensions, don't just give me one of them. Make sure you give me all 3. Okay? So the first thing here, nothing too fancy, just kind of create a model. But the main thing here is if I give you just the input, you can tell me the volume. So x will be your input, the volume will be your output. Let's try another one, but actually now maximize something. So this says I'm going to upgrade my hot pepper growing operation, got a little garden in the backyard, and I'm going to try and build a proper garden, and I'm going to just go to Home Depot and I just bought some stuff, and I got 120 feet of fencing. So what I'm going to do is just kind of sketch this out. If it's going to be a rectangle, which I think I should probably put in the description, we're going to say it's a rectangle, and we'll say this is the length and this is the width. And what I want to do is write a function that models the area and I'm saying here in terms of the width. So I want an equation that says A of W. I give you the width, you tell me the area. So what do we know? Well, first of all, 120 feet of fencing, that's not an area. That's a perimeter. Okay, so I know how much fence I have. So I'm going to say, well, I know the perimeter of every rectangle is 2L plus 2W. And I know in this problem I have 120 feet of fencing. So there's one equation I have. What else do I know? How do I find the area of this? Well, area is length times width. Cool. Now, I don't want length times width. I want area in terms of width, which means this variable has got to go. You can't use L if you're trying to find area in terms of width. You're only allowed to use W. So this is a system of equations that I'm going to condense into one equation. The way I'm going to do that is I'm going to find a substitution. So what I need to do is look at this equation and be like, can I get L by itself? How would I get L by itself in this equation? Well, first thing I would do is I would subtract 120 minus 2L. So take this equation, move the L's to the other side. I'm trying to get L by itself. Sorry. Let's flip that. If you're trying to get L by itself, you would do this. 2L equals 120 minus 2W. There you go. We're trying to get L by itself because we're trying to do a substitution with L. Then the next thing I'm going to do is divide everything by 2. So L equals 60 minus 1W. Remember, if you divide by 2, you got to divide everything by 2. So half of 120, half of 2. I have L is 60 minus W. So what I'm going to do now is combine these into one equation. So instead of A of W equals length times width, I'm going to say L, I know what L is. L is 60 minus W times width, W. So it's length times width, but the length is what I solved for. It's a substitution. Instead of L times W, I'm doing 60 minus W times W. And what that gives you is an equation just if you can tell me the width, I can tell you the area. So what we're going to do is now find the largest area of the garden. So this is where you want to graph it. And you can simplify this if you want. Either of these are okay. If you want to distribute it, 60W minus W squared. So what I'm going to do is look at the graph of this, and we'll see what that looks like. So I think I got it done already. Let's see, get out of here. Get out of here. This one. So here's my graph. 60W minus W squared. If it says maximize area, first thing you got to know what you're looking at. So let's scale this thing up. I'm holding the shift key down to do that. And here's my graph. So what you need to think about is what all of this stuff represents. What is the x-axis? What is the input in this function? The input is W, the width. So what this graph represents is the width. These are all different widths. So if the width is 60, then there will be no area. And then the y-axis is the output. So what's the output? The area. So what I have here is a picture where the x-axis represents the width and the y-axis represents the area. Let's just look at it on here. It might be easier. So if I want to label this, I want to say the x-axis here is the width of the garden and the y-axis is the area. That's what this function is telling us. So it says, first thing, what's the largest area you can create? To find the largest area, look at the picture. Okay, area is the y-axis, so where's the biggest spot? Right there. What's the y value? 900. So the largest area you could create would be 900 feet squared. How do you get 900 feet squared? Well, what's the x-axis? The width. If you want the width to be 30, then you will get the length of also 30. And I can come up here and 30 feet by 30 feet. I'm going to look at this now and say, how'd you get 30 feet for the length? Well, if the width is 30 and you plug it in right here, 60 minus 30, you get 30. So wait a minute, 30 by 30, it's a square? Yes. If you want to maximize area, given a perimeter, build a square. A square is sort of like the perfect shape. It's going to have the biggest area, the most bang for your buck. If you know you're trying to maximize area, the best way to do that is to build a square. And that's what this picture shows you. The biggest volume, or I'm sorry, area you can get is right here at 900, and that's when the width is 30, which means the length is also 30. But notice, the length isn't anywhere in this picture. You had to come up here to find the length. Use that little substitution. Okay, so we've done sort of one of each type of problem. Now I'm going to switch to the practice notes, and on the front of the practice problems, there's a couple that are just like this. So this says a breakfast cereal company manages to the same game as before. We're going to pretty much do the same problem we did before, but we're going to do it now with, I'm going to just steal this if I can. Can I just take this? Yeah, watch this. Copy. We'll go back over here and paste. There you go. Look at that lovely rectangular prism I drew. Okay. So it says, for aesthetic reasons, the box width is 3 times its depth, so we'll call this the depth again. The width is 3 of those, and the height is 5 of those. So almost exactly the same. Find the volume if the depth is 1.5. First, let's get a function, v of x. Find a function that models the volume in terms of its depth, so v of x. X times 3x times 5x. That's length times width times height. So the volume in terms of the width would be 3 times 5, which is 15x cubed. So almost exactly the same as before. Find the volume if the depth is 1.5. So I'm giving you a depth. Plug in 1.5. If you plug in 1.5, let's just use Desmos. So you can see I actually have, well, maybe you can see, I actually have this equation v of x, and since there's only one of those, maybe not, there's 2 of them. So I'm going to get rid of this guy. And now I'll see v of 1.5, and it'll actually plug it in for me into this function. So 50.625 would be the volume, 50.625, and that is inches cubed because you're in 3 dimensions. What depth is the volume? 90. So this is where you're working backwards. I'm giving you the volume. So 90 equals 15x cubed. First divide both sides by 15. So 90 over 15. Oops. Wait, what did I just do? Oh, I can't cross that one out. So I'm going to do 90 over 15, and then I'm going to take the cube root of that. So I'm going to need the calculator for at least part of that. So 90 over 15. Oops. Whoa, what is that? 90 over 15, 6. And I'll take the cube root. So nth root. The third root of 6 is we'll say 1.817, 1.82. 1.82 inches. Okay, and it just says for what depth? The depth would be 1.82. If you plug 1.82 in, you will then get the volume of 90. So 1.82 inches would be the depth if the volume is 90. So pretty much the same as the first one. Let's do one more. Gardner has 140 feet of fencing, so similar problem to the other rectangle one we did. We're going to go ahead and draw this all out. And what do we know? Find a function. Okay, so we're going to try and find area in terms of width again. So we'll call this the width. That's the length. And that's the width. Doesn't really matter. What do we know? We have 140 feet of fencing. Okay, so 2L plus 2W, oops, that's not a 2, 2W equals 140. That's what we know. We also know that area is length times width. So if I want area in terms of width, I got to get rid of this. I'm not allowed to write L's anywhere, so I got to isolate L in the top equation. I'm going to do a substitution. So 2W is 140 minus, I keep doing that, 2L is 140 minus 2W. You're trying to solve for L, so you can do a substitution. So solve for L. Then L is 70 minus 1W. Divide everything by 2. 70 minus 1W. So the area in terms of width would be, instead of writing L, I'm going to write 70 minus W times W. L times W. This is L, that's W. So 70 minus W times W, which I'll distribute 70W minus W squared. There's my model. For what range of widths is the area greater than or equal to 825? So we could do this algebraically, but I'm going to look at the graph here, and we'll use that. 70W minus W squared. So get rid of this. I don't need this. I don't need this. I don't need this. I don't need any of that. I want this one. Okay, so here's my graph. It says, for what range of widths will the area be greater than 825? Well, remember what we're looking at here. The x-axis is your input. That's the width. The y-axis is the output. That's the area. So first of all, if you want to maximize it, you would say the width is 35. But that's not what it asks. It says when is the volume greater than 825? Think about that. The volume, we're doing, area, not volume. The area is 825. So that's the output. If I say y equals 825, what I'm doing is I'm finding everywhere that the area is 825. So how do you get that to happen? Well, the first time that happens is when the width is 15. And then everything bigger than 15, you can see it goes up. We got bigger, 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 bigger. And then we get down to here, 55, the area is also 825. Past that, it starts to get smaller. So there's a range of values where it works, but there's also a range of values where it doesn't. These are all too small, and these are too big. So the range of widths that give you 825 are between 15 and 55, which I'm going to say 15, and these are feet. 15 is less than the width is less than 55 feet. Anything in between 15 and 55 works. 16, 17, 18, all the way up to 55. Those will give you areas bigger than 825. And the last thing is find the dimensions of the maximum area. So the maximum area would be right up here. The width is 35. And that would be feet. And then you could probably guess, since it's a rectangle, you can do this a couple ways. You could do 1225 divided by 35. So if you just want to see, 'cause if you don't necessarily believe me, if I do 1225 divided by 35, you can get the other dimension, which is 35. Or you can come and use the substitution formula down here. If the width is 35, 70 minus 35, the length is also 35. The length is 35 feet as well. And that will give you the area of 1225. Is that right? 1225? Yeah, 1225. And that would be feet squared because it's area. So the two main types of problems I need you to be able to do right now are volume and area. If you can do those, that's a good start for modeling. We're going to do our next video here, and they'll be a little bit fancier from there. But for now, that's a good start. So be sure to hit that like and subscribe button.